Today we're going to look at reflections as part of transformations. So our transformations with a focus on reflections. And we're going to start off with a warm-up, quick warm-up. You guys draw the hexagon and see how many lines of symmetry you can draw. So hexagons have 6 sides. And a line of symmetry is just going to draw a line that's going to cut the shape into 2 symmetric parts, 2 congruent parts that are equal in size and shape. So see how many places you can draw a line to cut that shape in half. All right, so if I draw a line just from one vertice through to another, that's one place. I could draw it straight up and down and cut that into 2 congruent parts. I could do another line here, I could do a line here, and actually I have 6 different places where I could draw a line of symmetry. So 6 different lines so it cut the hexagon in half. Now, a reflection we think of as a math term of reflection, but really what we're talking about is just flipping a shape over a line. And we call that line the line of reflection. So a line of reflection just takes the shape and flips it over that line. So we see this part that's closest to the line on this side, when it reflects over, it stays closest to the line here. Or this point that's the furthest from on the left side, when it flips over the line would be the furthest from on the right side. So a reflection or flip is a transformation in which a figure is reflected in a line called a line of reflection, and a reflection creates a mirror image of the original. So reflection, just like rotation and transformation, the shape stays congruent. It stays the exact same size and shape. So we're not changing the size, we're just flipping it over a line or a reflection. And if you think of it, if we took a mirror and we lined it up on that line of reflection, we would see the same image. So reflection, we reflect in mirrors, it's like a flip. So tell whether the blue figure is a reflection of the pink figure. Well, if I take this pink rectangle and I flip it over this line, it is a reflection. This point that's closest stays the closest. The point furthest away when it flips over is furthest away on the blue. So I would say that is a good example of reflection. The pink figure can be flipped to form the blue figure, so it's a reflection. How about on the right side? Can I flip that pink figure over the line of reflection to get the blue figure? No. So if the pink figure were flipped, it would point to the left. The blue figure is not a reflection. So this pointy part would be closest on the other side. So what this looks like is just a translation. It just looks like a slide, not a reflection, because it hadn't flipped over the line. Tell whether the blue figure is a reflection of the pink figure. Is the blue a reflection from the pink? So pink, would that reflect over? No, that one looks just like a slide or a translation. How about this one on the right? Is the blue figure a reflection of the pink figure? Yes. It looks like this just flipped right over that line, so that would be a reflection. So reflection just flips over the line like we did from blue to pink or pink to blue. Rotation would be when we turn about a given point, would be a rotation. And a translation is just a slide. If we take this F and we slide it across, just kind of like pushing a puzzle piece across the table, all 3 of these, reflection, rotation, and translation, all maintain congruency. They keep the same size and shape. All right, you guys can pause the video here and see if you can answer these questions, and we'll come back. All right, welcome back. Which one is the original figure? Well, I have this blue triangle, ABC, and then I have the red triangle, A prime, B prime, C prime. That prime or that little apostrophe prime notation means we have an image or a copy. So the original triangle, ABC. Name the type of transformation. Well, it looks to me like B is 2 to the left, B prime is 2 to the right, A is this distance. So it looks to me like triangle ABC has just been reflected over the y-axis to make A prime, B prime, C prime. So this is a reflection. Name the coordinates of the vertices of the image. All right, so my image A prime is at 1, 2, 3, 4, 4, 0. B prime is at 2, 0. And C prime, 1, 2, 3, 4, 1, 2, 3 is at 4, 4. Is triangle ABC congruent to its image? Is it the same size and shape? Yes. Both triangles are the same size and shape. Reflecting over the y-axis has not changed the size and shape. It is still the same size and shape. So it has maintained its congruency. All right, we have a triangle with points at -1, 1, -1, 3, and 6, 3. Draw the figure and its reflection in the x-axis, and what are the coordinates of the image? All right, pause the video here, reflect those 3 points over the x, and come up with our new triangle. All right, well, if I flip A over the x-axis, this point that's like 1 above will flip to be A prime at 1 below. This point at 1, 2, 3 above at B will flip to be 1, 2, 3 below the x at B prime. And then C that's at 1, 2, 3 spaces above the x, when I flip it over, it's going to be 3 below the x. And so we have our new triangle, A prime, B prime, C prime. And A prime is at -1, -1. B prime at -1, 1, 2, 3, -3. And C prime at 1, 2, 3, 4, 5, 1, 2, 3 at, 6. 1, 2, 3, 4, 5, 6, -3. Count your spaces, not your lines. All right. So, which one of these does not belong with the others? Which one of these is not the same? So, which transformation does not belong with the other 3? What do you think here? Well, this looks like a translation, not a reflection or rotation. This looks like reflection. The straight line that's on this side flips over to be the straight line, about the same distance from the line of reflection. The heart, the little point on this side, reflects over to be the little point on this side. So I think these are both reflections, and this one is not. This one looks like a translation or a slide. All right, let's try one that's a little harder. This one has 2 moves. You guys can pause the video here and answer the questions being asked. All right, so we're trying to find the coordinates of the figure after these transformations. We have reflect the trapezoid in the x-axis, then translate the trapezoid 2 units left and 3 units up. So we have 2 moves. We have 2 transformations back to back. And a lot of assessments have these kind of series of transformations, like this one with 2 different transformations. So to find where W prime is going to go, we're going to start with W, and if we just reflect it first over this X, it's going to go from 2 below to 2 above. Then we're going to go 2 to the left for our translation, and up 1, 2, 3, and that puts us at the point -4, 5. How about X? Well, X is starting 1 above. When I reflect it over the X, it's going to go down 1. It's going to be here to start. And then I need to do my moves for my translation. I need to go 2 to the left and up 1, 2, 3. So that puts me at -4, 2. And Y that starts 1 above is going to flip over the X and be 1 below. And then I need to do my translation. I need to go 2 to the left and up 1, 2, 3. I'm going to be at that point at 0, 2. And then Z that's 2 below is going to flip over the X to be 2 above. Then I need to do my translation of 2 to the left and up 1, 2, 3. And that puts me at the point 2, 5. And I hope that helps you guys get going on with your reflections. We have one quick real-world example to look at. Why would an ambulance want this decal on the front of their emergency vehicle? Why would you walk by a hospital and see an ambulance sitting there, and on the front hood it looks like the sticker like that? Why would they put a sticker like that in front of an ambulance? Well, if you're driving down the road, when you start driving, and you look up in a rearview mirror, it's actually going to read from left to right as saying ambulance. So it saves that split second of time for our mind to do the reflection and actually be able to see it like we normally do and read from left to right. is that would be a great real-world example of a reflection. Hope that helps you guys have a great day. OUT spells out.